Here's our goal for this video. This unit kind of contains two ideas. One is understanding the general structure of the periodic table, and one is understanding something called periodic trends. This video is kind of going to serve as a bridge between those two concepts. I want to introduce some terms to you that you need to understand in order to understand periodic trends. So, in terms of your learning targets, the most important things out of this video are I can explain how electron shielding affects elements or atoms, and I can identify how main group elements ionize based on the periodic table. So you have to understand ionization and a couple of these other terms in order to understand trends. So here are your first two terms to understand: nuclear charge and electron shielding. These are two phenomena that occur in every atom that will affect our trends. So oftentimes when I ask the question, why is a trend the way it is, you will answer either nuclear charge or electron shielding. What is a trend in general? You'll get into that tomorrow, but a trend is as you move across the periodic table and down, something happens, and it happens consistently, and that's a trend. Okay, the trend that going down the alkali metals, they become more reactive, that's a trend. So, nuclear charge. You know your nucleus is positive. It contains protons and neutrons. As you increase your number of protons within that nucleus, you will increase your nuclear charge. And that addition of protons and that increasing of nuclear charge will affect our trends. The other thing that's going to affect our trends are electron shielding. So, as you fill up one of your energy levels, remember your energy level is essentially a row on the periodic table. Within each energy level, you have sub-energy levels like S, P, D, and F, but an energy level is essentially a row on the periodic table. And as you fill up one of your rows, basically all those electrons are acting as a shield from the attraction of that nucleus. So your nucleus is positively charged. As you increase that charge, you will increase the positive aspect of the nucleus, but as you increase your electrons, you will increase the shielding of that nuclear attraction happening. So you consider any atom. Remember, your nucleus is positive, your electrons are negative. So part of just the structure of an atom is the fact that the protons are always pulling on the electrons. There is an attraction of the electron cloud with the nucleus. That attraction varies depending on how many protons are in the nucleus and how many energy levels are full. Okay? Nuclear charge, electron shielding. Again, you're going to use these to explain why the trends are the way they are. So what trends are we going to look at? We are going to look at these three trends. So you need to know what the terms mean before we look at the trends. Okay? So one trend we're going to look at is the trend of ionization or ionization energy. And ionization energy is the energy it takes to ionize an atom. Okay? So what does it mean to ionize? Well, ionizing is making it into an ion, which means doing stuff with your electrons. Specifically for ionization energy, it's the energy it takes to take away an electron, not to add one. Okay, so ionization energy is the energy it takes to remove an electron. And as we look at this, you'll actually see that there is a first ionization energy and a second and a third and a fourth for atoms, meaning there's an energy related to taking one electron away, which would be its first energy, and then there's energy related to taking a second one away and a third one away and a fourth one away. As you remove more electrons, the energy it takes will change depending on the atom. Okay. Another trend we're going to look at is a trend in electronegativity. So what is electronegativity? Electronegativity is a measure of the tendency or the ability of an atom to attract a bonding pair of electrons. Okay, this is just the weirdest one. Ionization energy is actually a measure of energy. It's in joules. It's an actual measurement. Electronegativity is this fuzzy kind of measurement because it's a tendency, the tendency of an atom to draw electrons to themselves. It's weird. And when I look at the actual numbers with you, when we look at trends, it's not the same as ionization energy. It's an actual, it's more of an idea of like a ranking, like, oh, this one draws electrons the most, So we're going to rate that a 4. And then all the other atoms of the periodic tables are going to get different ratings based on the fact that the strongest pull gets a 4. Because nothing's physically being removed or transferred, it's a harder one to measure. And again, how this works is when we get into bonding, there's 2 different ways you bond. You either remove electrons and like take them as your own, or you have to share them. And the tendency to share brings in this idea of electronegativity, in that when they share, sometimes they don't share equally. Maybe one atom has more of a tendency or ability to attract a bonding pair to itself, okay? And that atom would be more electronegative. Okay? So the more electronegative atoms have a greater tendency to pull electrons toward themselves. Remember, electrons are negative, which means somehow there's a positive draw pulling electrons towards the more electronegative atoms. Atomic radius is the 3rd trend we're going to look at, and the atomic radius is the size of an atom. But if you really start to think about size of an atom, it's a strange thing because you can't really picture, right, protons, neutrons, electrons, and it's not super easy to measure the size of an atom. So if you actually look at the scientific definition of the atomic radius, you'll see that what they do is they take diatomic atoms, okay, and they measure the distance between the 2 nuclei of diatomic atoms. And once they measure the 2 distance, halfway between them would be the radius. Okay, I'll show you a picture in a second, but your understanding can simply be that the atomic radius is the distance from the nucleus to our outermost energy level of the stable electrons, meaning not when they're jumping, right, but when they're in their stable configurations, it'd be to the outermost 90% probability electron would be there. That's the distance. Okay. How they actually do it is right here, as I mentioned. They take a diatomic atom. A diatomic atom is when 2 atoms of the same element are bonded, like if you have 2 chlorines bonded, or 2 oxygens bonded, or 2 hydrogens bonded. They take those diatomic atoms, they figure out the distance between the 2 nuclei, and then they half it, and that would be the radius. For ions, it's even harder, okay, to measure how big the atom is when it's ionized, meaning it's gained or lost electrons. This is usually done with crystallography. Okay, oftentimes ions make crystals, and they can actually look at the crystal structure using crystallography, and then sometimes actually measure distance. It's a lot harder, meaning our atomic radiuses are pretty right. We're pretty sure on most of them. Ionic radiuses, depending on what reference you look at, sometimes they're a little sketchy. This is kind of the base of what you need to know in order to do the trends. You're ready to do Form 2, and then from there we're going to move on to the periodic trends activity. Okay? Have an awesome night.